Hello everyone. Today we will discuss chapter number 3, theory of projections. So here in this slide you can see object which is nothing but a car, and different features of the car can be seen from different orientation. For example, the person from this side, he can see the front features of the car, whereas this person, he can see the rear features of the car. Side features can be seen either from this orientation or this orientation. So all these things, that how to obtain the projections, that we will discuss in this particular chapter. So the learning objectives are to know the elements of projections. So what are the various elements which are required to obtain the projections. Then we will discuss about the system of projections, then different methods which are being used to obtain the projections, and finally we will understand the various standard practices which are followed in our country for these projections. Elements of projections. So basically there are three elements of the projections. One is the object, second is the plane of projection, and third is the observer. The figure 1, here object is shown, then we have plane of projection and observer. If you see the sequence, here you will see that the object, plane of projection and observer is a sequence, whereas the second figure, the object comes in between plane of projection and observer. So based on the sequence of object, plane of projection and observer, the methods of projections are derived. System of projections. So we have multi-view projections, which in other words we call orthographic projections, and single view projections, which also called as the pictorial projections. Pictorial projections are further categorized as axonometric projections, oblique projections and perspective projections. In this chapter, our main objective to learn about the multi-view projections. Pictorial projections will be discussed in details when isometric chapter will be taught. Principal planes of projections. Basically, there are two planes which are intersecting at right angle are considered. The horizontal plane we call as the HP, vertical plane we call as the VP. Mutual intersection of both the planes generally we call as a reference line. There is a third plane which is mutually perpendicular to these two planes, which is called as the profile plane. For the projections, we obtain front view, side view and top view of the object. Front view in other language we call as the elevation, top view we call it as a plan or top view, and there is a right side view or left side view depending on the orientation of the observer. Principal planes and principal axis. So as I said, there are two planes which are mutually perpendicular to each other. Horizontal plane is called as the HP, vertical plane is called as the VP. So in figure, two planes are shown. The assumption is these two planes are infinite in the dimensions, transparent one, and these two planes divide the entire space into 4 regions. Each region we call as a quadrant. As I said, there are two planes which are mutually perpendicular to each other, horizontal plane and vertical plane. Both the planes divide entire space into 4 regions. Each region we call as a quadrant. There is a third plane which is mutually perpendicular to these two planes, which is called as the profile plane. The direction of observer, which is fixed for the projections. So the arrow, it indicates the direction observer position to view the front view, and it is fixed whether the object is kept in the first quadrant, second quadrant, third quadrant or fourth quadrant. So quadrant description will be first quadrant, which is above HP and in front of VP. So first quadrant is the region which is above the horizontal plane and in front of the vertical plane, whereas the fourth quadrant, the description is it is the region which is below the horizontal plane and in front of vertical plane. So observer position to see the top view is also fixed, which is shown here. The second quadrant, the description will be, it is the region which is above horizontal plane and behind the vertical plane. Now the thing which is to be understood here, the position of observer will be remain same. For front view, observer will be here, whereas the first quadrant and fourth quadrant will be nearer to the observer. For top view, observer position will be here, whereas first quadrant and second quadrant will be nearer to the observer. And third quadrant, which is described as the region which is below HP and behind VP, and this quadrant, it will be always away from the observer. For front view, observer position is here at this particular point, so third quadrant is away. For top view, observer is here, the third quadrant is away. Then principal axis, this is the x axis which is described. Similarly, we can describe other axis, that is y axis, and this particular axis is the z axis. So these are the principal axis. There is a third plane which is mutually perpendicular to horizontal plane and vertical plane, which we call as the profile plane. In short, it is PP. Okay. So here first quadrant, horizontal plane, vertical plane and profile plane is shown. If object is kept here, then front view will be projected on vertical plane, top view will be projected on the horizontal plane, side view will be projected on the profile plane. So always we consider front view, top view and visible side view. In this case, when front view will be seen here, so visible side view will be the left hand side view. Then once these projections are projected, then we bring those projections in single plane. The process to bring them in single plane is to rotate the reference planes. So which planes are rotated? Vertical plane is remains same. Horizontal plane, it is to be rotated in such a way that first quadrant will be open. So when first quadrant will be open, the third quadrant will also be open. How it is? Because horizontal plane, it is assumed to be hinged at intersection of horizontal plane and vertical plane. So it is assumed to be hinged at this particular line. So about this line, when horizontal plane, it will be rotated, this part will go up. So first quadrant and third quadrant will be open. Similar way, we have to rotate the profile plane such way that first quadrant will be open, then profile plane must be rotated in this direction. So these are the rotations of the planes. So let me demonstrate it with the help of the model. Here in this model, I have vertical plane, I have horizontal plane. Description of the quadrant, the region which is above the horizontal plane in front of the vertical plane is the first quadrant. The region which is above horizontal plane behind the vertical plane is the second quadrant. The region which is below horizontal plane and behind vertical plane is the third quadrant. The region which is below the horizontal plane and in front of the vertical plane is fourth quadrant. Observer is here for front view. This is first quadrant, observer is here. So my hand, it indicates the direction position of the observer. So first quadrant and fourth quadrant is nearer to the observer. For top view, observer will be here. So first quadrant and second quadrant will be nearer to the observer. Okay. And if suppose the object which is placed here, this particular object is placed here, then observer will be here. So front view will be projected on the vertical plane. So front view will be projected on the vertical plane. Okay. Top view, it will be projected on the horizontal plane. Now you see the sequence: observer you have, object you have, and plane of projection you have. When object is kept in the first quadrant. Okay. Then for top view also, observer is here, object is here, and plane of projection is here. So once the front view is projected, top view is projected, then we have to bring front view and top view in a single plane by rotating the horizontal plane. So how it is done? We have to rotate the horizontal plane from the hinge point. When we rotate it, the horizontal plane will be rotated like this. Then you will find front view and top view. Front view will be here, top view will be here. This will happen when object is kept in the first quadrant. Similarly, we can keep the object in any of the quadrants. Like for example, we have kept it in the first quadrant, then we can keep it in the second quadrant, third quadrant as well as fourth quadrant. But we'll see that which are the suitable quadrants where we can place the object. So first method is first angle method of projections. So first angle method of projection is the method when we keep the object in the first quadrant and obtain the projections. So in given figure, the object is kept in the first quadrant. We have vertical plane, we have horizontal plane, we have profile plane. The observer is shown who can see the front view. When the observer will see the front view will be projected on the vertical plane. For top view, observer will see from here. So the position of observer remains fixed. For front view, observer will be here. For top view, observer will be here. So top view will be projected on the horizontal plane, and the visible side view is the right side view. So observer will be here and he will see the object. So this is the situation when this is the first quadrant, object is kept in the first quadrant. So we have here observer here, then front view will be projected on vertical plane, then observer is here, top view will be projected on the horizontal plane, then right hand side view which is visible, suppose from your side, then profile plane will be somewhere here. Once these projections are plotted, then we need to rotate the horizontal plane. So horizontal plane is rotated such way that first quadrant will be open. So you will find here front view, top view and profile plane was here, which will be rotated in this way. It was here and it will be rotated in this way. So front view you will get here, top view you will get here. So for this case, when you obtain the projections, horizontal plane will be rotated, profile plane will be rotated. So you will get the projections given in this diagram, where you have front view, exactly below the front view you have top view, and then you have right side view which appears left hand side of the front view. I would like to discuss the first angle method projections, where the first quadrant is considered, object is kept. So front view, it will be projected on vertical plane, top view will be projected on horizontal plane. Then now side view. So we'll have to see that which is the visible side view, whether right hand side view or left hand side view. If suppose observer is at this side, this is a view which is seen to the observer, then this plane is not to be considered. So we have here the front view which will be projected on the vertical plane, top view is projected on horizontal plane, and left hand side view which is projected on the profile plane. Once the views are projected, then we need to rotate the plane. So profile plane is rotated such way that the quadrant is open, and at the same time horizontal plane is rotated, so you can see the top view. So first angle method of projections, we have front view, exactly below front view you have top view, and right side view will appear left hand side of the front view. If you see the left side view, it will appear right side of the front view. Coming to the third angle method of projections. In third angle method of projections, the object is kept in the third quadrant. As I shown, this is the third quadrant, object will be kept in the third quadrant. However, position of observer will be remain same here for front view. These planes are the transparent one. Since the planes are transparent one, you have observer, plane of projection, and then object. Observer, plane of projection, and object for front view. For top view, observer will be here. So you have observer, plane of projection, and then object. So first angle method of projection, we keep object in the first quadrant. Third angle method of projection, we keep object in the third quadrant. Now let us consider the third quadrant. Object is kept in the third quadrant. The position of observer for front view, observer, plane of projection, and then object. So front view will be projected on the vertical plane. For top view, we have observer, of projection, and object. So top view will be projected on the horizontal plane. Now coming to the side view, which is the visible side view. If suppose right hand side view will be visible, then observer will be this side. Observer, plane of projection, this is the profile plane, and then object. If left hand side view will be visible, then observer, plane of projection, and then object. So let us consider right hand side view is the visible one. So observer is on that side and he will see the right hand side view on this particular profile plane. Once these planes are projected, then we have to open the quadrant by rotating the horizontal plane and profile plane. So horizontal plane, it will be rotated and profile plane will be rotated, and then you will be able to see the top view, front view, and right hand side view. Now here if you see in third angle method of projection, you have front view, exactly above the front view you have top view, and right hand side of the front view you have right hand side view. So this is the difference between first angle method of projection and third angle method of projection. So as I said, the third angle method of projection, you have front view, then you have exactly above the front view you have top view, and right hand side of the front view you have right side view. Where in first angle method of projections we had front view, exactly below front view we had top view, and left side of the front view we had right side view. So this is the difference between first angle method of projection and third angle method of projection. Now the question is, if we keep the object in second or fourth quadrant, then what will happen? Let us again consider the model. If suppose object is kept in the second quadrant, observer position is remain same. Observer will be here for front view, observer will be here for top view. So front view will be projected on vertical plane, top view will be projected on horizontal plane. Then when you will rotate the planes will be rotated like this. The rotation, what we said, that first and third quadrant will open. So second quadrant and fourth quadrant will be getting close. So what you will have, that you will have the front view and top view, both will overlap on each other. So it will be difficult to identify front view and top view. Same thing happen when you keep object in the fourth quadrant. So object, when it will be in the fourth quadrant, front view you have on the vertical plane, top view you have on the horizontal plane. When the plane will be rotated, front view and top view will be overlapped. So you will not be able to identify the front view and top view. Therefore we will not keep the object in fourth or second quadrant. So we have two method of projections, first angle method of projection and third angle method of projections. One may ask the question, if we open first and third quadrant, instead of that, why not to open second and fourth quadrant? If second and fourth quadrant will be open, then one can obtain the projections, but it is not done. Why? Because the standard practices we follow for this course, that the rotation of horizontal plane is such that first and third quadrant is open. Because as introductory class I said engineering graphics is nothing but a language of the engineers. There are certain rules, like for English language or some other language, there are certain rules for the grammars. Same way, there are certain rules which are made for the engineering graphics. So as far as those rules are concerned, in order to follow the standard practice, it has decided that when rotation of the horizontal plane is made, it will be such that first and third quadrant will be open. Therefore, we don't go for the second and fourth quadrant. Let us have example which is solved with the third angle method of projections. So we have object, we have observer. So wherever the direction arrow is shown, that is nothing but the direction to view the front view. So observer will see front view from this direction. For top view, observer will be at this particular point, and side view, this is obviously we have a right side view which will be seen from this particular side. We have third angle method of projection. So observer will have plane of projection and object. So it is assumed that at each corner of the object a bulb is kept and which illuminates the light perpendicular to the plane of projection. For example, when I want to see the front view on the vertical plane, the bulb will illuminate the light, and then the projections we will obtain on the vertical plane. So in this diagram, as you can see, at each corner, from each corner you have you can assume the light rays which are perpendicular to the vertical plane, and we can see the projection of this object on vertical plane. Similar way, we can obtain the top view. Assumption is same, that each corner of the object bulb is kept which illuminates the light perpendicular to the reference plane. So with that assumption, we obtain the top view on the horizontal plane. Similar way, we obtain the side view on profile plane. Then next step, we have to open the quadrant. So when we open the quadrant by rotating horizontal plane and profile plane, we obtain these three figures in a single plane. So we can see here the object which is kept inside the quadrant and then projections. So we have front view, exactly above front view we have top view, and right hand side of the front view we have right hand side view. This is in the third angle method of projections. This slide, it shows the comparison between first angle method of projection and third angle method of projections. So first diagram, it shows the third quadrant. We have direction of arrow for front view. So we have observer, then we have plane of projection and object. For top view also, we have observer, plane of projection and object. Side view also, visible side view is right side view. So we have observer, plane of projection and object. So once the projections are obtained on the reference plane, we have to open the quadrant. When we open the quadrant, we will find the front view. Exactly above front view there is a top view, and right hand side of the front view, right side view. A similar way, second figure, it shows for first angle method of projection. First quadrant is shown. This is the direction. For front view, we have observer, object and plane of projection. For top view, we have observer, object and plane of projection. For side view, the visible side view is again right side view. We have observer, object and plane of projection. Once all projections obtained on the reference plane, we have to open the quadrant by rotating the horizontal plane and profile plane. Upon opening the planes, we obtain the figure where we have front view. Exactly below the front view, we have top view, and right side view, it appears left hand side of the front view. So this is the difference between first angle method of projection and third angle method of projection. Again the question, why not to second and third quadrant is used to obtain the projections? So as I discussed earlier, that if suppose second and fourth quadrant we consider, when we rotate the horizontal plane, then front view and top view area is overlapped, and in such case we will not be able to distinguish the front view and top view. Therefore, second and fourth quadrant is not used to obtain the projections. Only first and third quadrant is used. ISI code of practice for the projections. So basically, first angle method of projection is the practice which is followed in the British standards, whereas third angle method of projections, it is followed in the America and European continents. In India, earlier first angle method of projection was followed, but later on Indian Standard Institute, they have formulated the standards and given the guidelines. According to those guidelines, third angle method of projection was recommended in India, but later version of the standard, it is revised that the choice to use the standards is left with the users. So user can choose either first angle method of projection or third angle method of projection, by considering that user may receive the drawings from different corner of the words. So in that case, user must be able to understand the projections which are drawn in either of the standards. Symbolic representation for first angle method of projection and third angle method of projection. So this symbol, it is represented with the help of frustum of the cone. In first diagram, the frustum of the cone, it is kept in the first quadrant. The arrow, it indicates the direction of observer. We have observer, object and plane of projection, and visible side view is the right hand side view. So observer in front view can see the trapezium. In side view, he can see the top and bottom base of the cone. So side view is nothing but the two concentric circles, and side view, it is right hand side view which appears left hand side of the front view. Whereas second diagram, it shows the object is in third quadrant. Arrow, it indicates the direction of observer for the front view. We have observer, plane of projection and object. So front view will appear as a trapezium. The visible side view is the left hand side view which appears left hand side of the front view. So these are the symbolic representations for first angle method of projection and third angle method of projection. So in this class, we have discussed about the elements of projections. So there are three elements of projections, like the observer, object and plane of projections. Briefly we discuss about the system of projections. Then we discuss about the method of projections. There are two methods, first angle method of projections and third angle method of projections. And finally we have end up with the symbolic representation of first angle method of projection and third angle method of projection. Thank you.